All right, today we're going to do some welding with gas shielded flux core. It's also called dual shield. We'll weld some different thicknesses and cut them apart to see the penetration we got. We'll run a vertical weld and we'll talk about the setup and the pros and cons of running dual shield wire. So one of the biggest advantages in my mind of running gas shielded flux core compared with solid wire is that you can weld uphill with a stringer bead and have nice hot settings, just about the same that you'd have when you're running in a flat or horizontal position. So if you notice, I'm just keeping that wire up on the leading edge of the puddle. What I like to picture is a glass of water filling up, and you just keep your finger right on that surface as it fills up. Now, the important thing here is to watch your angles, and I like to, of course, be heading in there about 45 degrees, but use just a very slight push angle when I'm going uphill with this wire, and you can just have confidence in the process that that slag is going to hold it in place, but it is pretty sensitive. Any little variation in your movement, you'll see you can end up with some just little wiggles and wobbles. But for a vertical weld running a straight stringer on wire feed, I mean, that's really pretty good in my opinion. And people who run this all day, every day, I mean, I'm an engineer nerd talking about it, but people who run it all day, every day, you can get pretty smooth. So let me show you something here at the start of this weld. Those are worm tracks, and that's where gas was not able to escape out from under the flux in time. And so you end up with those little discontinuities there. Usually they're pretty surface level, but the main reason that this happens is if you're using too short of a stick out. And so if your wire doesn't have some length to it, it can't preheat on the way in. So if you hold a longer stick out, it's a lot better. Notice the rest of this weld is completely clean. Let's talk a little bit about the setup. So the wire itself is gas shielded flux core. ESAB's trade name is dual shield. Lincoln's is outer shield. Now I'm using 045 or 1.2 millimeter diameter wire. The gas that runs with it depends on the wire itself. It's either, usually at least, a 75-25 argon CO2 blend like you'd run with solid wire, or straight CO2. And some wires can run either one. At the end of the wire designation, it's E71T-1. At the end, it'll either have an M or a C, M for mixed gas and C for CO2. Now, another consideration with flux core wire of any sort is the drive rolls. So these are knurled drive rolls. See those little grooves to help push the tubular wire without having to pinch down on it too hard. Let's take a look at the machine setup and settings here. So I'm using the HCP MIG 2800 today, and the last time I used this, I just used it in manual mode. So when you first turn it on, it's just wire speed and voltage, old school, and you can just leave it like that and never mess with any of the settings inside. But if you go to MIG 2T, then you can enter some synergic settings. And since I don't run a lot of dual shield flux core, I just went through here and you select your wire type. And now when I turn the wire speed knob, it changes my voltage as well. And that top left LCD shows the estimated amperage that I'm gonna have. So this is what I set it to right here, about 250 inches per minute. And since I was running vertical up on that last weld, I just dialed it back about a volt or so from what was recommended, and that worked really well for me. I probably didn't even need to dial it back, but it was helpful. So in addition to being able to run out of position like that, there are a few other advantages of running a dual shield flux core. There are also some disadvantages we'll talk about later in the video, but another one of the advantages is that you can get good penetration, or at least better weld penetration than you get with short circuit MIG. So we're going to go ahead and test that out here. Now, since I'm not running in the vertical position, I'm just going to turn up my wire speed and amperage a little bit, and also just go with the recommended voltage that they had. And these settings were kind of spot on. Now, notice I'm using a slight drag angle here. This is debated, and let me know in the comments if you run a lot of dual shield, what you do. A lot of people actually run a push angle. I'm kind of in the if there's slag, you drag camp, but the slag is so light in this case that you can often run a push angle, and it seems to do okay. But either one, you just don't want to get too carried away with, and run it nice and consistent all the way across. And you have some light slag, usually isn't too bad to remove here, but you can see it catches every little wiggle and wobble that you have. So let's go ahead and cut this apart and take a look to see what kind of penetration we got on this 1/4 inch. All right, let's take a look at the weld penetration on this 1/4 inch thick plate. So this light region here, I've etched the weld to show where the actual weld metal is. and it's penetrated into this vertical plate as well as the horizontal plate. Well, I think it'll hold. Now I want to try something just a little bit thicker, so I'm going to go ahead and turn up my wire speed, and that'll increase my amperage as well, and then run here on some 1/2 inch thick plate. Notice once again, I'm just using that very slight drag angle. The biggest thing is to keep those angles very consistent as you weld along. Now notice that slag following right behind your weld pool, and it's not too bad to actually read the weld puddle. It reminds me a lot of 7018 where that slag follows right behind, but this slag freezes really fast, which is one of the things that's pretty helpful in the vertical position. I'm holding that little bit longer stick out once again, and that seems to work. Now, dual shield, it is a pretty runny puddle, and so it's pretty sensitive to any little movements that you have. So you'll notice there are a few little inconsistencies on that lower toe right there. The upper toe is pretty consistent, but any little movement, it's going to capture it. On the left, that looks like a little bit of undercut. I didn't notice any in real life, so I'm not sure if that's just part of the image or maybe there is a little bit there, but its size is right about 1/4 inch, and then on that lower leg about 1/4 inch on the smaller parts, and the bigger parts are just a little over, so let's cut it apart. So I've etched the weld here on this 1/2 inch thick plate once again, and you can see I did get some penetration into the vertical plate and into the horizontal plate on this thick material, and it did just barely come down and kiss that corner of the weld. So this is in the acceptable region, but I wouldn't mind a little bit more penetration. I think with a little bit hotter settings, I could probably get there. When I'm setting up for these videos, I usually cut an extra set of coupons because sometimes I need to take a mulligan on one of my shots, but I didn't this time, so I figured for practice sake, I'll run one more, and I felt pretty good about that one. Now, a couple other advantages of dual shield flux core are just the bead appearance. You can get a nice, smooth, clean bead. I just like the way that they look a lot of the time. And also the properties. Now, people talk a lot about strength of a metal, but there's a lot of mechanical properties that aren't strength, and one of them is toughness. And the toughness of a weld, like strength when it gets impacted, is quite a bit higher a lot of times when you're running dual shield, so that can be a big advantage. Now let's talk about some of the disadvantages of running a dual shield flux core, and the first one comes up as soon as you go to buy it. It's about twice the price of your standard solid wire. So you're going to be spending more up front. Now you can save some of that on productivity if that makes sense, but generally speaking, solid wire is going to be more economical, and you're using gas either way. Now, another drawback to running the dual shield flux core is the fume that you get. It is a smoky and pretty dirty process, so I'm fortunate to have a fume extractor here, but if you don't have one, it can smoke out a pretty big room pretty fast, and you end up with a bunch of just little fine dust all over everything when you run a dual shield flux core. So that can be another disadvantage. Now, something else to keep in mind is not all machines will really run a dual shield wire well, so you need to have, at least like a 200 amp class machine to run some 035 dual shield well. All right, well, if you have any questions or comments, or if you run this stuff all the time and have some other things to add, let me know down in the comments section below. And if you enjoyed this or learned something, let me know by hitting that thumbs up below. Now, if you are just getting started with welding and you're trying to teach yourself in your garage or your own shop, and you want to be able to learn faster, I have some affordable online courses linked in the description below that I'll walk you through everything that you need to know step by step to get up and going with the basics. So be sure to check those out. We'll see you next time.